Hey makers, welcome to another episode. I hope you are doing fine. Now, I did not upload a single video for almost a month right now, and I have a good reason for that. It's just that I've been working non-stop on my DIY CNC machine. So basically I've made version number 1 and version number 1.2, which is a lot sturdier. So in this video I will try to break out a little things about the CNC machine. So basically I will not show you how to make my own. Basically I'm gonna show you the model that it was a source of my inspirations and the model that I actually built upon. So maybe you will like to make this model instead of mine because it's cheaper, but it's less sturdier than my own design. So it's not like I don't have videos of me making my DIY CNC machine. In fact, I do have so much videos that I'm not sure how am I going to form it and put it in one video. I mean, if you have any ideas on how I should, like, I have around 60 gigabytes of footage, actually high quality footage of me making the assembly and all that kind of stuff. So yeah, so I hope this series will be good, and if you have anything that you want me to change, please do. So today it's gonna be basically an introduction to CNC machines for people who don't know what's a CNC, but you know, just clicked on this video for some unknown reason. So let's start with that. So what's a CNC? CNC stands for computer numerical control. So long story short, it's a machine that you can control using a computer. Now there are some people that are debating whether or not a 3D printer is actually a CNC machine, because here's the thing: you can use programs like Printerface to control a CNC machine using your computer, or you can just use an SD card and a built-in screen, LCD screen, to just, you know, move the CNC and basically print the parts from G-code. So in this case you are not using a computer, so I'm not sure if it's a CNC, but a lot of people, when we talk about the CNC, we mean basically this kind of stuff. So if you are familiar with 3D printers, so what does a 3D printer is basically you have what we call an extruder. So it's this part right here. It has a resistance. So when the filament goes in, it's actually getting heat up to a melting point, then it's going to add layers. So it's additive manufacturing. So we add layer by layer. Now a CNC is actually the opposite of that. So we use, for example, this is a router CNC. It has a router that has a end mill. So basically it's a cutting tool that will just remove materials layer by layer. So 3D printer, we add layer by layer, and in a CNC router we basically remove layer by layer. And a lot of people, when we say CNC machine, they will think about this type of machine that has a router and they will cut material, because for example, laser cutter is actually a CNC machine, but where we don't say a laser cutter with we don't say a CNC machine with a laser model that can cut something. We just say laser cutter. So when we say a CNC machine, we actually mean these type of machines. Now there are a lot of variety of CNC machines. For example, this one right here, this is the 3080 CNC machine, which is very affordable. It goes for around $200 depending on where you buy it from and depending on shipping and that kind of stuff. Actually, a friend of mine bought this and we had a look at its performance, and this was the reason why I did not do the CNC that I'm going to show you right now. So basically this is very affordable CNC, well, affordable depending on where you live and your budget and that kind of stuff, but it's more than capable machine. You can do engrave PCBs on it, you can cut acrylic, you can cut softwoods, and there are a lot of people that just took this CNC machine and upgraded to another level. So basically they changed this 150 watt spindle to 500 watt. They were even able to cut aluminium on it. So that's something that you probably should have a look at. Now one of the CNC that I really like is this Shipoko CNC. So it basically uses a big spindle. It's a DeWalt, and there are some models that have a Makita. This, I'm not sure how strong this thing, it's definitely beyond 500 watt, and the build volume and the sturdiness. Now there are YouTubers that use this machine. I forgot its name. I'm gonna put it somewhere on the screen. So he used it to cut aluminium and this machine is more than capable. Just that I live in Tunisia, and the shipping and the customers tax and all that kind of stuff is gonna be way over my budget since I'm still a student. So I had to make my own DIY CNC machine, and for that we are going to have a look at the design that I made. Now remember the 3080 CNC machine, I went to Thingiverse to have a look at a template. So at first I didn't want to spend time making my own design, which I end up doing, and it took me 5 months to make my own CNC machine. So basically I found this on Thingiverse 4 months ago, and you can know that by the fact that I put a comment on this post like June 3, 2020, and we are going to have a look at why I put this in just a minute. So first of all, the thing that I don't like about this CNC, even though it says here DIY 3080 CNC machine, it's not the 3080 CNC machine. So basically 3080 CNC machine, it does have a 30 by 80 centimeters cutting area. So 30 by 80, that's why it got the name 30 by 80. Now this one right here, if we go to description, it's actually, it has a working area of 20 by 10. So it's like 2010, not 3080. I'm not sure why he named it that. I mean, this got me confused. I mean, I said that I wanted to make the design, so I actually bought the aluminium extrusions before I had a look at the description. I know it sounds stupid, but I just wanted to get the CNC done. So basically I bought the extrusions, then I had to talk with my friends, and he said that there are some problems with the 3080 CNC machine, so we're gonna talk about in just a second. But basically I had to shift my design and my CNC machine from this to the one that I've been posting videos all over the place about, and I actually 3D printed all the parts for the CNC machine. If you have any ideas on what I should do with them, let me know in the comments. So yeah, so let's have a look at why I did not like this design and the reason I changed it to my own design. So long story short, this 3080 CNC machine, it uses 10mm rods on the axis and the Y, and 8mm rods on the Z axis. Now I talked with my friend when he got his CNC machine. I said, hey, give me brief summary of your experience, and he basically said that he cannot go very fast, the feed rate. So basically the feed rate is the speed of the machine while it's cutting. So he said he cannot go very fast because the machine will start shaking, and he can feel that the rods flexing, and this is very common because these are unsupported rods. There are some supported rods, they just cost insanely expensive, especially in my country. So I've been thinking that if those 10mm rods have problems, then these 8mm will definitely have problem. Yes, this CNC machine, it has 8mm rods on the X and Y, everything 8mm. Yes, it is going to save you costs since 10mm bearings and 10mm rods are more expensive than the 8mm. Actually, my DIY CNC machines is 12mm, not 10, not 8, 12, so it's a lot sturdier, but it meant that I had to spend an extra money to get that sturdiness, which probably some people are on a low budget that they cannot afford. So this 8mm it's a good alternative. And if we have a look at the pictures right here, we can actually say that he did manage to cut MDF with it. Probably he went slow, but it done the job. Okay, so as a CNC machine, it works perfectly fine, and for engraving on PCB, it's gonna work with no problems. It's just that when you're making a CNC for PCB, be ready because the bits are very fragile and they will basically destroy themselves very quickly. I actually had to destroy around 10 bits to actually figure out how to properly machine with them. Now, if you've been following me on my Instagram account and Facebook page, you will see that I actually put a Dremel first as my router, and actually a lot of people have been asking me on my Facebook page whether or not it was a good alternative for the 775 motor. Now, the reason why I did use a Dremel first, because I was not able to find the 775 motor in my country, and I had a Dremel at hand. So what I did is I took this design and I basically adapted to my Dremel. So this is the design. I spent I don't know, about 10 good hours in SolidWorks importing things from all over the place. So basically I did use GrabCAD to get the SolidWorks for these stepper motors, and these are STL files. As you can see, it has a lot of traces going over, because I basically downloaded the files that I found here, which you can find everything here, and I had to change them to SolidWorks file. Basically I saved them on my computer and then I just imported them one by one into SolidWorks, and I've made the assembly. It took a lot of time, but it was worth it, and I've done that because of one comment. Now this is the comment that really led me to basically do all this work. This one right here. So basically someone, which I'm very thankful for, he said there is probably there is a problem in the parts, so he actually included this. So basically he did the assembly and he found that this rod does not fit, so there is a small problem in here, and that actually led me to make the assembly, because I was not sure whether or not the other parts will fit correctly, and in fact they did fit correctly. So the only problem was in this part, and the way I fixed this is basically I made the hole bigger. So basically, long story short, I took his file, which he put for free. So this is the file that he made. Where is it? Where is the file? Come on. Someone posted the files and I just took it. I'm not sure who, probably in the remix section if I remember correctly. So that's okay. So it's here. It should be, this is the y-axis bearing. It should be right here. And yes, this is, someone posted this STL, which I took, and then I had to change it. So basically I was not able to find the small bearing. So normally here and here there is a small bearing, which I ordered from China before the virus and the pandemic, but they never arrived, and I had everything at hand, only I was waiting for these two bearings to finish the build. Actually, you can build the build, you can build the machine even without them. And when you don't know anything about CNC machine and you never built one, you're kind of skeptical about what you need and what you don't. But from my experience, and after I built this machine, basically 2.5 or 1.5, I mean it is the same machine, just that on another level. Anyway, you don't need these parts, but if you are planning to use them anyway, I just made them a little bit bigger, so you can fit a bigger size bearing that you can find everywhere. If I could find them in my country, then you can find, I will actually put the number of the bearings exactly on the screen, so you can just use that reference to buy the bearings. So what I did, this is my Dremel. So what I did was I actually made the hole a little bit bigger. So this is the original STL file. So first I made two circles right here, so it can actually help me in the assembly process on SolidWorks, because you need to make you need these rods. Where is it? You actually need like a circle to actually say, hey, I want this to be coaxial to some other things. And in STL, it's not a perfect circle. It's like a small segment. So yeah, that's something you don't have to worry about. But what I've done, basically, I made this hole fits my Dremel. So at first it did not fit. Well, I had two Dremels, one fit and one did not, so I actually had to modify it a little bit further, and I end up with a diameter of 48. So if you have a Dremel that has a 48 shaft or body cylindrical diameter, then it's going to fit absolutely fine. If not, then you will have to change the STL files. And actually changing the STL files in SolidWorks is very easy. You just have to first import it, and you just think about it as, I don't know, any simple piece. You just click on it and, for example, say, hey, I want to sketch and I don't know, you just say, hey, I want this, I want to do that. It's a little bit laggy because I have a lot of programs running. So come on, this is a little bit embarrassing. And I know, for example, if you want to boost extrude, yeah, you can just extrude and hit OK, and it's basically going to extrude. Yeah, it's lagging, so let's just close this. I don't want my computer to freeze on me while I'm recording because that will suck. So this is basically the first design. So the only thing that I changed was I made this part a little bit bigger, and I made these parts a little bit different so it can fit a bigger size bearing. Now, of course, if you don't have a Dremel, you can use this 775 motor. Actually, someone posted on my Facebook page saying, hey, does it get hot? Does it affect the PLA? Actually, it does not get hot enough to melt the PLA. If you want to melt the PLA or deform it, you need something above 60 degrees. And this motor, I've been running it for, I've ran it one time for around 5 hours straight. So basically I had to work for a client, so he wanted 5 PCBs delivered in a short amount of time. So I've been running the CNC non-stop, and I had absolutely no problems. Well, the only problem I had was that my PLA cracked because I'm not sure why. I mean, I've missed a lot. I mean, I've missed when cutting acrylic, and I've missed when trying to cut wood. I've done a lot of mistakes, and I'm sure one of them was the reason why my PLA cracked. I'm going to talk more about these things in the future. I know the video is a little bit long, but there are a lot of information that I want to put in, and yeah, if you think that it's a little bit long, just let me know in the comments. So basically this is the design. If you want this design, I will probably going to leave an STL files in the link in the description. I'm not sure if I should. I mean, I will make a remix of this on my Thingiverse account, and I just gonna put the step files, so maybe you want to have the assembly or something, I don't know. So this is the version, basically the same version. Now I've done a second version which in attempt to make it a little bit sturdier. So what I've done is I made another axis on the back, because here's the thing, when you're cutting, your rods will actually flex. Now, of course, all this was before I contacted my friends and he told me that his CNC flex. So after he told me it flex, I had to change everything, and yeah, that took like another month to develop and that kind of stuff. So I will make another video where I show you my two designs that I changed a lot of things on them. And yeah, if you like this video, I'll probably going to make 2-3 more videos where I show the assembly, and I'm going to talk about whether or not using a Dremel or the 7.7 motor, which is the best choice, the type of couplers, the motor torques, and a lot of things about the CNC machine. Just give me a little bit of time, since I started I started school again and I don't have that much time. Anyway, so what I've done is I extruded a piece right here that fits an 8mm bearings, and you can put an X in here. Now this was in the hope to add an extra strengthening rod to the system, so when you're cutting or when you're milling, it's not going to flex. Now note that I did not print this, and depending on your printing accuracy, it may or may not result some problems, especially because this is a tight tolerance, since you need to be so this and this will have to be perfectly positioned. Because here's the thing, these rods, even if one of them is a little bit, you know, moved like by, I don't know, by fraction of a millimeter, it's not gonna be a problem, because each rod has its own support here. But in this here, you will actually need to be this, and that will have to be perfectly dimensioned. So depending on your 3D printer, this may or may not work, but hey, it's not that. You can just print it like a shell with, I don't know, 20% infill and try. Maybe if it does not, you can always modify this piece. I will be putting this step too in the link in the description. If you don't find it now, I will put it soon. So this is the upgrade that I've done. Of course, we have the rods here and everything. Then I decided, you know what, why don't I just add 2 additional motors? Now my CNC machine actually had 5 motors, which one of them in the y-axis I'm not using, because when I built my enclosure, which is the black one that you cannot see there, when I close the enclosure, the stepper motor actually does not let the door close, so I actually have to find a way to fit a smaller motor or something so the door can close. Because here's the thing, a CNC without an enclosure is bad news, especially if you live in an apartment where you have neighbors and roommates. You know, I have neighbors above me, below me, and I have my roommates here, which running a CNC at full, speed is not a good idea. It makes a lot of dust and a lot of noises. So if you are making your own CNC machine, this is something to consider. Of course, there are some spindles which are silent. The 300 watt silent spindle that goes for around, I don't know, $33 on AliExpress. It's definitely a good deal. Well, I can't buy it because with my customers' fees in my country, it's gonna be way expensive. Anyway, so what I've done is I added 2 motors right here. So basically I mirrored this motor and its support on this side. Actually, there are some problems with this support. It actually flexes when you apply too much force in here. I felt that this piece flex. Now note that this piece are 3D printed. Of course, in the original design, he used aluminiums. You can definitely get away with 3D printer parts in the y-axis, but in the x-axis you definitely need aluminium because of the weight of the X carriage. If you are going to use 3D printer parts with the force of cutting, and it's going to break. But on the x-axis, on the other hand, it's fine. It's not going to break or anything. Now someone on my Facebook page asking me what's the reason behind putting 2 motors, and some people actually thought that the reason why I did that because I was not able to find suitable bearings for the axis. Actually, it's very simple. You can think of a car that has a motor that controls 2 wheels and another car that have a motor that controls 4 wheels. Which one has more torque? Which one can run in terrains without a problem, that can go on mountains and in a very bad environments? The one that the motor can actually move the 4 wheels, because it's going to have more torque. We are not talking about speed here, it's more torque, because when you are cutting, if you go a little bit deeper, then the force of the cut will be stronger than your motor torque, so your motor will actually start skipping steps. In 3D printer, when you go very fast or maybe your pulley is not tightening well, you will have skipping steps and layer shift. Now in the CNC you will have something like that, and it's gonna be worse because if you have a layer shift, your end mill will probably break and you will have to toss your part away. And some stock are very expensive, like aluminium. I mean, you cannot risk having your CNC breaking aluminium end mill and ruining your stock, since aluminium is relatively expensive. That's why you need to be conservative on how much you cut your material, and the more torque the better. For example, in the Shipoko, this one right here, it uses a big motors. It does not use the NEMA 70 motors. I think it's NEMA 23 something like that. I'm not sure, I forgot. You can definitely check that out. But hey, NEMA 70 is not that strong. And if you are asking me why I not go with something bigger, just that if I want to buy a bigger stepper motors, it's gonna cost me around 3 times the price of NEMA 70, and the driver itself will cost around, I don't know, like 10 times the price of the NEMA 17 driver. So it's way over my budget, and it's definitely an overkill for this small CNC machine. I mean, my DIY CNC machine, it has a footprint of 170 centimeters by 200. So it has more working space than this machine. I don't know why. I'm not sure why, but it does. It's probably to the fact that I'm actually having these closer to what they should. I absolutely have no idea. Probably he stated these wrong. I know, probably. Actually, another CNC machine that I found that I think that is interesting is this CNC 3080 DIY, which I'm not sure why I did not see it. No idea, but I think this CNC is actually real 30 by 80 by the rods, and here you see for 400 is basically identical to the one that you buy, the 3080 CNC machine. So this is really a viable choice, just that he used 8mm bearings, which, as I said, is not the sturdiest thing. So you definitely wanna use, I don't know, at least 10mm or 12. Now the only reason I did not use 16 or 20mm is because of the price. If I had enough money, I would definitely went with 20 or 60mm at least rods and bearings, but the price will just go very insanely high over my budget. So with this video we are basically done. I hope you learned something, and in the next video I will be showing my DIY CNC machine. We are going to talk a little bit about the things that I did differently from this file. Of course, this file you will find it in the link in the description. Maybe you will need the step files, or I don't know, suit yourself. And in the future I will be basically showing you how to assemble my own DIY CNC machine, and I'll probably going to leave a bill basically where I bought my parts from Tunisia, since we don't have Amazon here, and basically finding the cheapest components can be a little bit difficult, sorry. So yeah, long story short, I hope you enjoyed this long video, and I will see you in the next one. Peace.